Energy transformation demonstration 1. So this is a hand boiler. Now it doesn't boil my hand, but look at what my hand can do to it. So I'm going to place it in my hand, and you can instantly see that fluid begin to rise, and then, whoa, whoa. Let's get it a little warmer. Oh yeah, there we go. So I don't know if you guys can hear it, but I'll do that sound effect for you because it's going blip, 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 blip. So what's happening here? So we have energy coming from my hand. What energy is that? So it's called a hand boiler. So that means it's probably, thermal energy. And that's converting or transforming into, it's heating up the liquid and making it move. So that's, okay, but not just kinetic, it's mechanical. Very good. And because of that, blah, 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 we also have sound. So thermal energy converting the fluid, making it move into, so that's transforming into mechanical energy, and sound because we get some blah, 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 blah happening. Okay? Energy transformation demo number 2, popcorn maker. Okay, so let's check this out. So what I've done is I've plugged this thing in, and now I'm going to add some popcorn kernels. Now this is kind of an extra step, but I also have to add some oil because of this type of maker. Put the lid on, it's plugged in, so now here we go. Switch on. Let me take you guys on a little field trip. So think about the energy being transformed here. So we started off with electrical energy. And that electrical energy is heating this up. Once it gets hot enough, something is going to happen that you've probably seen before. But when? All right, it is getting warm. I'm starting to smell it. You can even smell that thermal energy, especially as it heats that oil. Make sure our lid's on nice and tight. Okay, so we can start to see some steam forming. That means it's getting really warm. Thermal energy is getting pretty powerful, almost powerful enough to make a corn kernel. Oh, so I saw one, but it was a wee one. Let's see if we can get a little more going. Aha. Okay, so let's talk about what just happened there. Ooh, some condensation happening. Okay, so I started with these corn kernels. Now I have this popcorn. I plugged the thing in, it got hot, and then this happened. So what just happened? So when I plugged it in, it got electrical. Yeah, very good. And then as it heated up, that was, yep, that was thermal. And then, okay, so one thing you guys would notice is that it was spinning as it was cooking. We're not technically going to count that, but if you guys said that as soon as the electrical started, it also did mechanical, that's technically true, but we're not going to count that in our answer. So it went from electrical to thermal, and then, yeah, then mechanical. So we actually saw the popping. There was some sound there. So it went from, electrical to thermal to mechanical and sound. And if I heat it, I'm getting some type of energy. So once this becomes food, it's in the form of, you got it, chemical. Very good. So that is our answer here. We are going from from electrical to thermal to mechanical and sound. Energy transformation number 3. Okay, so what we are doing here is a homopolar motor, aka a magnetic motor, because this thing is super cool. So I have some magnets. It's a little stack of magnets. It's just the box they came in, but I've stuck them to their box. So it's a stack of magnets. These are super powerful magnets. And I have a AA battery. I'm going to place this AA battery on top of my stack of magnets. And then here I have my tiny dancer. Oh, she's so beautiful, the tiny dancer. So she is made, she's a girl, why not? This is made of copper wire. What are some things we know about copper wire? So some properties, some physical properties, or just general properties of copper wire. Oh, it's a conductor. Yeah. So we know that it's a conductor, which means it can conduct heat, but also it can conduct electricity. Very good. So since we know copper wire is a conductor and my tiny dancer is made of copper wire, I have some magnets with a battery here, and I have to balance her just right. The tool, the blue stuff, is just because that's her little tutu. Looks a lot better when she's dancing. So I have to balance it just right, which is difficult when I'm holding it like this, but there she goes. Oh, it's so difficult to hold up like this. Oh, it's so powerful. I might need less magnets. Come on, dancer, dance. Oh my goodness. So it's really difficult when you're holding it up. I should have done this on a flat surface, but you can see her starting to spin. So what's interesting about this is the number of magnets controls the amount the amount of power that it's receiving. So if I trim it down, maybe I only do 3 magnets. There's going to be less force applied to my tiny dancer, and because she's not receiving as much power, she's a little easier to stabilize. It's once she starts spinning really fast that it's a little more difficult to keep her balanced. So you guys can see, hold me closer, tiny dancer. Okay. Oh, I wonder if I can just set her right there. It's kind of a flat surface. Whew, she is a rebel. There she goes. So you can kind of see her. So there's my tiny dancer. So what's happening here while she dances? So we have a battery. The battery is, man, she is really difficult to stabilize today. Unstable dancer. So the battery is providing chemical energy, very good. And then that chemical energy is being converted into, she's spinning. Mechanical, yeah. So this is mechanical energy. Now the thing is, technically, there's something happening in between there. So this, because of the magnets, this is actually what we call electromagnetic energy. So we are converting chemical energy into electrical energy, and then that is transferring over to our tiny dancer into mechanical energy. So yeah, there it is. Super cool. All of these materials were ordered on Amazon if you want to make your own. Energy transformation number 4. Number 4 is instruments. I ended up not bringing my guitar today. I got worried about bringing my guitar in the car and the trip, and you have to have a guitar stand and you have to have the strap and everything. So I got worried about my guitar. Maybe I can record a guitar video for you guys from home. But what I do have is Mr. Nolan's drumsticks. So there it was right there. It just happened. There's my energy transformation. Okay. So what am I doing? This is the same thing if you play a guitar. It's the same thing if you, gosh, I mean, pretty much any instrument you play, this is happening. Okay, so right now, are the drumsticks making noise? That's not how drumsticks work. So I have to do this. So I'm moving them. Yeah, that's mechanical. So I'm transforming mechanical energy into sound. You got it. So this is just mechanical energy being transformed into sound energy. Way cooler when I'm holding a guitar because I also don't have a drum. But most instruments, that's how they work. Energy transformation number 4 was drums, and this is number 5. So energy transformation number 5, flashlight. Okay, well, first off, what do we know about a flashlight? Inside here we have some batteries. Those batteries are connected to a coil, and that coil presses up against this light bulb. Okay, so let's see. Oh, whoa, what's happening here? So I turn the light switch off. When the switch is off, the circuit is open. When the switch is on, the circuit is closed and it starts producing light. So what's happening here? How's it doing that? So the batteries are storing what type of energy? Chemical, yep. So the batteries are storing chemical energy. That chemical energy is, once I connect a circuit, so circuits have to do with like wires, closing a circuit. That would be electrical. Yep. So that's electrical energy. So we have batteries storing chemical energy, which is being transformed into electrical energy. And then finally, that is creating light. Light is also called, what's our 7th grade word for light energy? Radiant. So we have chemical to electrical to radiant. Flashlight. Mrs. Raspberry, you are suddenly wearing safety gear. Why ever would you be doing that? Well, because we're on energy transformation number 6, which is a match. Since I'm dealing with fire, it's very important that I'm wearing my proper safety gear in a science laboratory. So we have matches. Now, matches have a chemical stored on the tip of the match. So it's wood with some stuff at the tip, phosphorus. And then we also have a thing to strike right here. So another material right here for striking. So when I do this, what have I done? Okay. So wood, burning, the act of burning, and wood itself stores a certain type of energy. So like burning is that physical, or what type of reaction is that? Oh yeah, so we learned that's a chemical reaction. The reason burning, especially wood burning, is a chemical reaction is because wood stores what type of energy? Chemical. Yeah, it's a chemical reaction because wood stores chemical energy. We even have extra chemicals here at the tip to make sure that it ignites and reacts. So we have stored chemical energy and it's being transformed into fire, which is radiant and thermal. Radiant and thermal. So actually double checking because I realized that they kind of happen at the same time and I want to make sure you guys get them in the correct order. Yeah, so make sure you say radiant and thermal on your answers because that does matter. It has to be in the correct order for you to get it counted correctly on your assessment. So chemical to radiant and thermal. Match. Hey guys, so what I'm going to do is I'm going to use one of our matches from our last example for energy transformation number 6. Oh, come on, computer. 7, I knew it was a number off. So I'm going to use a match from energy transformation number 6 to light our candle for energy transformation number 7. Okay, so I have a candle here. The candle is lit. Here I have a magic snake. Okay, so this is a spinning snake, and I am going to hold him by his leash over this candle, and look at what he does. Whoa. Have you guys ever heard the phrase heat rises? Okay, so let's talk about what we just saw. So I had a candle lit, right? That candle is storing. Okay, so good. I wanted you guys to think about that. That candle is storing chemical energy, but in this case, that's not part of the energy transformation that we're talking about. So I just want to make sure you guys know that really the first thing that happened is that this is storing some chemical energy. However, this chemical energy is lit. So technically, if we're starting from when it's lit, we have thermal. Yep. So we have the thermal energy from this candle rising up and causing the magic snake, the spinning snake, to spin. And the reason that he's spinning is because that thermal energy, that heat, is rising. And because of the way the snake is shaped, it's causing it to spin. And that spinning is what type of energy? It is. It's mechanical. So we have thermal to mechanical here. And if you guys notice that, yeah, it's technically starting with chemical to power that thermal energy, that is very true. We're just not using that in the actual answer bank. So, yeah. Spinning snake. Numero ocho, number 8, a rubber band. And you know what? If anybody's met me, you know I'm a little bit clumsy, so I'm going to protect my eyes for this one too. So I have a rubber band. I don't know if you've ever done this, and if you haven't, be careful when you do. If you have, be careful when you do. Do not fire these at people. However, I will show you that I'm stretching this rubber band between 2 fingers. Oh, and it shot. Okay, so I just launched this. I launched this little rubber band. When I stretch this rubber band, I am making it store potential mechanical energy. Very good. So this is some potential energy, and that potential energy is getting launched into mechanical energy. So potential to mechanical. Welcome, welcome to demo number 9. I'm about to plug something in. It was a hair dryer. So I just plugged in this hair dryer. And now when I switch it on, we find out that I need to press the reset button. And now when I switch it on, okay, anyhow. So what I just did was I started with, okay, so I plugged it in. Electrical, yeah. So we plug it in and get electrical energy. Then I flip on the power switch. So that electrical energy starts spinning this motor thing, right? It's like a little fan inside there. And that starts making the air shoot out. So the electrical energy is converting into, yeah, so it's kind of 2 things at the same time, right? It's mechanical and thermal. And that is the order that we have it in our answer bank. So make sure you guys do that in the correct order. So technically, as soon as you switch it on, the first thing that happens, that fan starts spinning, but it also starts heating a coil. So it goes from electrical to mechanical and thermal. And then we get more mechanical things happening. Energy transformation number 10. Okay, so here's our last one. Ish. I have a little bit more to show you guys, but this is the last one on our actual assignment. So, windmill generator. So I have this thing just balanced on top of a water bottle. That's mainly just for weight and for holding it down. So as you guys can see here, I have a windmill. This windmill is connected to some gears inside this. Those gears are connected to a generator, a very, very small miniature generator. And that generator has some wires connecting down here to a light bulb, which you can't really see, but you're about to. So one thing you guys will notice is since this is such a high power generator, I can't just blow it like that. So my breath is not strong enough. It needs about 15 to 20 mile per hour winds in order to generate. And instead of taking you guys outside, I decided to just go ahead and simulate it by spinning it. So my finger is the wind in this case. So when I spin it, you can see, hopefully you guys can see that. Yeah, you can see it blinking in the video. So the interesting thing here is that it would take the wind constantly blowing to power this thing. So it would have to do and 15 to 20 miles per hour consistently in order to keep that bulb lit. Oh, so you guys can see that it's blinking because one spin is not generating enough power to keep it lit. It needs to keep on spinning. So if I took it out in high powered wind, which Unfortunately, we had a couple days ago. We don't have today. If I took this out in high-powered wind, then you would get to see it, and as it continued to spin, that light bulb would stay lit because it's getting enough power. In this case, it's not getting enough power to stay lit, it's just getting enough power to light up once. So one blink per spin is pretty much all I'm getting, and I'm lucky if I'm even getting that. So the wind moving across these, that is what kind of energy? Yeah, mechanical. So that is mechanical energy. That mechanical energy is transferring, converting, well, it's transferring at this point. It's transferring to this little generator. So it's actually that mechanical energy is turning these gears. These gears, as they spin, are powering this generator. So this generator and these wires are what type of energy? Wires. Like it's completing a circuit again. So that's electrical. Yeah. And then that electrical energy is powering this light bulb, which is occasionally giving off what type of energy? Light energy. That's our 6th grade word, though. What's our 7th grade word for light energy? Radiant. Good. So that's what's happening here. This is mechanical energy transferring to, wait. Yeah. This is mechanical energy, and it's transforming into electrical energy, which is then transforming into radiant energy. So that is what's happening here in our windmill generator. Now, if this was just a windmill, then it would just be mechanical to electrical, I guess, technically speaking. So, but usually the whole reason that we use windmills is to convert them to electricity that can then power other things like light bulbs. So, windmill generator. Okay. And the last thing I want to show you guys, just because it's awesome. So a little bonus example. Okay, so let me do that one thing. There we go. Okay, so what is this doing? I would have sliced my arm off, but I wanted it to make the sound again. Okay. Okay, so this guy right here has batteries inside it. Those batteries are stored potential energy in the form of chemicals, yes. So the batteries inside here are chemical energy. That is, as soon as I turn it on, that is transforming into electrical energy. And then that electrical energy is producing light and sound. So we actually have radiant and sound energy coming out of this as well. So all sorts of cool things happening in a lightsaber, in a toy lightsaber. If this were a real lightsaber, the chemical energy would be coming from, I didn't snap something off, did I? Was that always hollow? um, so if this were a real lightsaber, obviously your chemical energy is stormed in like a crystal, and there's a whole lot going there. There would be a whole lot of thermal energy coming out right here. This wouldn't be plastic. This would be a laser. So there's a lot more going on if this were real, but it's not. Womp, womp. So that was our little bonus demo. So thank you guys so much for watching. I also wanted to show you my larger snake that I made. So another one of our snake spinners is right here. I gave him a tongue, so that's pretty cool. So yeah, Thank you guys for watching the energy transformations. Feel free to try some of these at home, the safe ones. And no matter which one you try, make sure you do have your parents' permission. But those were our energy transformations. So much fun. Woo!